Hello, today we're going to have a look at circles and tangents. So this is normally how questions follow up the basic circle questions, by looking at tangents. The key bit of information that you really need to know for these questions is that the angle between the radius, so here I've got my radius, and my tangent, here I've got my tangent, this angle in here is always a right angle if it's between the radius and the tangent. And there are two main ways that questions exploit this. Either they'll give you the equation of a circle and will ask you to find the equation of a tangent at a certain point, or they will ask you to use Pythagoras in some way. Let's have a look at the first example. So here's the question from the AQA Core 1 paper. The circle with centre 5, 8. They've given us a nice convenient picture, so let's add on all our information onto that. It touches the y-axis, so we can see that my circle is touching my y-axis, and we're asked to find the standard equation of our circle. So for that, I know that I'm going to need x minus the x coordinate of the centre, well that's going to be 5, and then y minus my y coordinate of my centre, which is 8, and then that is equal to my radius. Now it's not given me the radius, but it has told me that my circle touches the y-axis, so I know that this distance must be my radius. And don't get confused by the fact that it's talking about y values, because actually the radius is how far I'm going along the x-axis. So you can say I'm going 5 along the x-axis, so this is equal to 5 squared, because it's equal to my radius squared, so equals 25. Part BI asks us to verify that the point A, 212, lies on the circle. There are two ways that you could do this. You could find the distance between the centre, 5, 8, and 212, and show that that distance is 5, which is the radius. Or, and probably the easiest way to do this, is to substitute 2 in, see what you get, and then hopefully you'll find out that your y value will be equal to 12. So if I substitute 2 in, I get 2 minus 5 squared plus y minus 8 squared equals 25. This is minus 3 squared is 9, so I get 9 plus y minus 8 squared equals 25. I get y minus 8 squared equals 16. So y minus 8 equals plus or minus 4. So y equals, when I take 4 as being the square root, I get 4 plus 8 is 12. Or if I take minus 4, I get minus 4 plus 8, which is just 4. And then you can see we have our x equals 2 and our y equals 12. So 212 does satisfy my equation. You'd want a sentence at the end just to explain that. Find an equation of the tangent of the circle at the point A. So this is what I'm saying is our normal question. We've got a point A somewhere on our circle at 212, so somewhere around here, and we're asked to find the equation of the tangent to the circle. Now we don't have very much information. To find the equation of a line, because of course a tangent is a line, I need 2 bits of information. I need a coordinate on the line, and we've got that. We know that 212 is on my line, but the other thing that I need is the gradient. And I don't have the gradient immediately available to me, but what I can use is the fact that I know that the radius is perpendicular to the tangent. So if I can find the gradient for radius, then I can find the gradient of the tangent, then I can find the equation for my tangent. So to find the gradient of my radius, there are 3 ways of finding the gradient in Core 1. You could differentiate, but we're not going to do that. You could rearrange the equation for line, but we don't have the equation of the line to rearrange. Or you could do change in y over change in x is equal to the gradient. And I do have 2 sets of coordinates. I have the centre and I have point A. So I'm going to do, looking at my radius, I can say that my gradient is my change in y over my change in x. And the two coordinates which I'm using are 2, 12, and my centre, which was 5, 8. So to go from 12 to 8, I'm going down 4, so I'm going to say minus 4. And to go from 2 to 5, I'm going up 3, so I'm going to say that the gradient is minus 4/3. So my perpendicular gradient, remember, is the negative reciprocal. You need to know all your core 1 coordinate geometry really well for this. So the negative reciprocal is going to be 3/4. Now I've got the gradient, I've got 3/4, and I've got a coordinate on my line, I've got 2, 12. I can now find the equation of my line using y minus y1 equals mx minus x1. So I get y minus, now the coordinate is for 2, 12, it's not the centre's not on my tangent, equals my gradient 3/4 and then x minus 2. To finish off, I need to get my tangent into the correct form. So I'm going to multiply through by 4 because I want it all to be integers. So that's going to give me 4y minus 48 equals 3x minus 2. And now I expand out my brackets. 4y minus 48 equals 3x minus 6. And collect everything on one side. So I'm going to collect it all on the side with the x. So I can say 3x minus 4y. And then I get minus 6 plus 48 becomes plus 42. And now I have it in the form that it wanted, so I've finished the question. So quite a common question. The key thing is to remember that the gradient for tangent and the gradient for radius are perpendicular, and that you can find the gradient for radius using change in y over change in x. I said there were two fairly common questions. One was to find the equation for tangent. The other one is to use Pythagoras to find a distance. So you can see if I'm given a point outside my circle, which the tangent is on, I get a right angle triangle, and I can use Pythagoras on that right angle triangle. Here's the AQA question from January 2013. A circle with centre minus 3, 2 has equation there. Find the y coordinates for the point where the circle crosses the y-axis. Well, we know that to find where a graph intercepts the y-axis, we change our x values to 0. So I get y squared minus 4y equals 12. And now we just have to solve this quadratic. So I'm going to say y squared minus 4y minus 12 equals 0. And then this will factorise to y minus 6, y plus 2. It's always worth expanding your brackets once you factorise because it's so much easier to expand brackets than to factorise. And I can say y equals 6, y equals minus 2. Nice simple 3 marks there. Find the radius of our circle. To find the radius, we have two options. Either I can put this into our standard circle form, or because I know what the centre is, and I know a coordinate, I know that 0, 6 is on my circle, I can just find the distance between 0, 6 and minus 3, 2, and that will be my radius. So I'm going to take that approach. I'm going to use Pythagoras. I'm going to go from minus 3, 2 to 0, 6, and just do a bit of Pythagoras. To go from minus 3 to 0, I'm going across 3. To go from 2 to 6, I'm going up 4. And then hopefully you can see that this is a 3, 4, 5 triangle. So my radius is going to be 5. The point 25 lies outside the circle. Find the length of C to P, giving your answer in the form root n. So again, nice straightforward Pythagoras question. I have my centre at minus 3, 2. I have my point P at 2, 5. So to go from -3 to 2, I'm going across 5, and to go from 2 up to 5, I'm going up 3. And then doing Pythagoras, I get 5 squared is 25, 3 squared is 9, 25 plus 9 is 34, so we get the square root of 34 as being my root n. Finally, we're told that the point Q lies on the circle, so that PQ is a tangent to the circle, and we're asked to find the length of P to Q. So we've got this sort of situation here. We've got P outside my circle, I've got Q as being a point on my circle, and we're asked for this distance, the distance of this tangent. We know that the radius of my triangle is 5, we know that the distance between my centre and my p-value is root 34, because we did it earlier on in the question. And then the key thing here is to spot that it's just Pythagoras, and if you have a picture, that will make it a lot easier. I know I go on about using pictures, but they really do make a difference. I can say PQ squared plus 5 squared equals the square root of 34 squared. So we get PQ squared plus 25 equals 34. So PQ squared equals 34, take away 25 is 9. So the distance from P to Q is going to be plus or minus 3. And because it's a distance, it must be plus 3. So these are fairly standard follow-up questions, just taking advantage of the fact that we know from our GCSE circle theorems that the angle between the radius and the tangent is always going to be 90 degrees.